Hello guys, in this video we are going to discuss the solution of the problem mobile number keypad. So let us look at the problem statement. The problem statement says that there is a standard numeric keypad on a mobile phone. You can only press the current button or the button that are directly up, left, right or down from it. For example, if you press 5, then pressing 2, 4, 6 and 8 are allowed. Diagonal movements and pressing the bottom row, corner, star and hash are prohibited. So what we need to do is, given a number n, find the number of possible unique sequence of length n that you can create by pressing buttons. So for instance, if the value of n is equals to 1, then the numbers which we will be able to press are these numbers, because of which we are returning 10. Similarly, for case where n is equals to 2, the various numbers which we will be able to press are 36, and that is why we are returning 36 in this case. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take few examples. So for instance, when the value of n was equals to 1, so let us say this is the pad which we have, and the value of n which is given to us is 1, which simply means we want to compute for length is equals to 1. So let us say this is the box which we have, and in this box, since we are supposed to press just 1, so either we can press 0 or we can press 1 or we can press 2, and similarly we can press all the numbers which are there in the pad for ones, because of which the answer for in this case will be equals to 10. Now let's move on to the next example. Let us say here n is equals to 2, so we will have two boxes with us. Now let us say in the first box, or the first number which we are pressing is 0. Now once we press 0, how many options do we have? So remember, 0 is here. Now the valid options are 8 and 0 itself. These are the only two valid options which we have. So for that reason, the valid combination of length 2 will be, these are the two valid combinations, which is 0, 0 or 0, 8. Because of which for n equals to 2, and if we press 0 initially, the value will be 2. Now it might be possible that the first number which we are pressing is 1. So in that case, 1 will be our starting point. And as we can see from 1, which is this case, from 1 we can either go to 2, or we can go to 4, or we can press 1 itself. So here we have three combinations or three options to choose from. So 1, either we can press 1, or we can press 2, or we can press 4. And similarly for rest of the numbers as well. So let us take one more example. So for instance, if the first number which we are pressing is 2, then in such case the options which we have is 1, 3 and 5 and 2 itself. So these are the options which we have, because of which with 2 the combinations or the valid answers are 2, 1, 2, 3, 2, 5 and 2, 2, which is 4. And if we add all the resultant numbers, so for instance here it is 2 and here it is 3 and for 2 it is 4. Similarly, if we compute for rest of the numbers and if we add them, then the resultant value we will obtain is 36. Now let us solve for n is equals to 3. So for n is equals to 3, let us say the first number which we pressed is 0. Now once we press 0, we know that the legal moves which we have is 0 and 8. These are the two legal moves which we have. Again we have encountered 0. So for 0 again we know that the legal moves are 0 and 8. Similarly, if we see 8, what are the legal moves for 8? So let us look at our pad. The legal moves for 8 are 5, 7, 9, 0 and 8 itself. So these are the legal moves. In this way, for n is equals to 3 and if we are starting with 0th, then the legal moves which we have are 1, 2, 3, 4, 5 and 6. So 6 legal moves from 0. Now if we analyze it a bit further, what we realize is, in order to solve for n is equals to 3, we can rely on the solutions for n is equals to 2. Now let us see how we can do that. Now when n is equals to 3, we saw that the legal move is 0 and 8. Now once we are at this position, once we are at this level, now our subproblem has been reduced to for n is equals to 2, because one string we have already consumed. So now our solution got reduced to n is equals to 2 for 0 and 8. And remember, since we have already solved our problem for n is equals to 2, so we know that for n equals to 2, and if we are starting from 0, then the legal moves are this, which is 0 and 8. That is how we have formed 0 and 8 here. Similarly, for 8, the legal moves are these, which are 5, 7, 9 and 8. And that also is coming from n equals to 2 solution. So in this way, we will be able to use previous solution in order to solve the current solution. So let me depict it in the form of a table, and then that it will make a lot of sense how we will be able to use previous solution in order to solve the current solution. So for this reason, what we will need is a DP table. So let us say this is the DP table which we have. So here the row, if you see, these values I am talking about. These values are the numpad values. On pad, the number is 0. On pad, the number is 1, and so on till 9. And the columns are n is equals to 1, the value of n. And for n equals to 1, what should be its value? For n equals to 2, what should be its value? And so on. Now, if you see, as we have already discussed that if n is equals to 1, then each of these pads can be pressed once, because of which for all these cases, the value is 1. So for all these, the value is 1. And if we want to find out the total number of unique strings, so the total number of unique string will be found out just by adding all these values. So in this case, this is equals to 10. So now let us populate for n is equals to 2. So as we know that for 0, we have only 2 valid options, because of which we are going to mark it as 2. Similarly, for 1, let us see how many valid options which we have. So for 1, we have 3 valid options, which is 1, 2 and 4. So these are the 3 valid options which we have, because of which we are going to mark it as 3. Similarly, for 2, the valid options which we have are 4. So here we are going to mark it as 4. Similarly, for the rest of the elements. So let me populate it. You can do it on your own in order to convince yourself that these values which I am putting is correct. So these are the values. And for n is equals to 2, if you want to find out the total number of unique sequences, then we have to add this column, and the resultant value we will obtain is 36. Now let us see how for n is equals to 3 we can rely on n equals to 2 in order to solve this problem. So let us see how for n equals to 3, and if we are starting from 0, what will be the total number of unique sequences starting from 0. So as we know, from 0 the legal moves are these, which is 0 and 8. Now we are at this level, and at this level n is equals to 2. Here at this level n was equals to 3. And when we reach to this level, n becomes equals to 2, because we have already consumed one string from there, or one letter from there. Now for n is equals to 2, and if we are starting from 0, we have already solved that problem. Now let us look at our DP table in order to find the solution. Well, for n equals to 2, and if we are starting from 0, the value is 2. So we know that this will result into 2. Similarly, for n is equals to 2, and if we are starting from 8, what is the solution which we have? Well, the solution is 5. So in this case, this will be equals to 5, and that will be our answer. So for n equals to 3, and if we are starting from 0, then the valid sequences, or the number of unique sequences starting from 0, will be equals to 2 plus 5, which is equals to 7. And that is what we are going to put here. Similarly, now let us solve for n equals to 3, and the starting letter is 1. So for n equals to 3, and let us say we are starting from 1, and n is equals to 3, then from 1, what are the legal moves which we have? For n, if n is equals to 1, the legal moves are 2, 4 and 1 itself. So these are the legal moves which we have. So these are the legal moves, and again here n becomes equals to 2, and since we have already solved this problem, which is for n equals to 2, and if we are starting from 2, similarly n equals to 2, and if we are starting from 4, and n equals to 2, and if we are starting from 1. Well, for n equals to 2, and if we are starting from 1, we already know the solution, which is equals to 3. So this will be 3. N equals to 2, and if we are starting from 4, so let us look at our DP table. N equals to 2, and if we are starting from 4, then the value is 4. So here it will be 4. Similarly, if n equals to 2 and it is starting from 2, then in that case the value is 4. So this is the value. And if we want to find the solution for n equals to 3 and starting position is 1, then the answer is 4 plus 4 plus 3, which is equals to 11. And that is what the value will be updated here. Similarly, we can solve for the rest of the values. And if you want to compute the total number of unique sequences for n equals to 3, then we have to add this column, and whatever value will come here will be our answer. So that's the general logic, folks. Now let us discuss the pseudocode for this problem. So let us say we want to find out the count and n is given to us. So in order to solve this, let us say we will have a pad with us, and the value of pad will be something like this. So the entire pad is what we are going to keep it in an array. So this is the pad which we have, and if we look at this pad, the dimension of this pad is 4 by 3. So this is a matrix of dimension 4 rows and 3 columns. Now once we have this pad with us, what we are going to do is we will need a DP table. And what will be the size of this DP table? So let me just go here in order to discuss the size of this DP table. Well, how many rows we need? The total number of rows is 10. So we know that the number of rows will be 10. And how many columns do we need? Well, the columns we need is n. So this will be the dimension of our DP table, which is 10 by n. And remember, since we have to go all the way till n, so rather than creating a DP table of dimension 10 by n, we will be creating a DP table of dimension 10 by n plus 1. So this is how we will be able to create a DP table of dimension 10 by n plus 1. So once we have these two info with us, what we are going to do is, so the first thing which we are going to do a base case. So if n is equals to 1, then we can simply return 10, because we know in that case the only solution is just pressing the button individually, and that will give us 10. So that is what we can return it. Now let us initialize the DP table. So for I in range of 10, what we are going to do is DP of I comma 1 equals to 1. So this essentially what I am doing here is, this part is what I have initialized. So this column, if you see this column, so all these values should be 1, is what I have initialized through this loop, which is I in range of 10, DP of I comma 1 equals to 1. Now once we have initialized it, now let us iterate for the rest of the length. So for I, so remember we have already solved for n equals to 1 here. This we have already solved for n equals to 1, and this is also a solution for n equals to 1. So because of which now we will iterate for n equals to 2 to all the way till n plus 1. So for I in a range of 2 to n plus 1. Now for each length we want to iterate on the numbers 0 to 9, which is we want to iterate on the pad in order to see what will be the total number of unique sequences starting from that letter for length I. So let me explain that. So let us first iterate on pad. So for j in range 4, so remember the pad is of dimension 4 by 3, and for k in range 3. So these two loops, if you see, these two loops is to iterate on pads. And why we are iterating on pads? Well, we are just iterating on pads so that we can get numbers 0, 1, 2, 3 and so on till 9. And we can also determine whether what are the legal moves and what moves we have to explore further. Now let's move forward. So the first thing which we have to see is that when we are iterating on pad, then the pad value, so pad of j comma k, not in star or hash. So if it is a star or hash, we can't do anything about it. So that is why I'm skipping it. So if it is not star or hash, then that simply means that it is a number ranging from 0 to 9. So now let us first get our number in int format. So integer of pad j comma k. Remember the values in pad are in character format. That is why I'm converting it into index format. So once we have index with us, now we have to explore for the legal moves. So remember the legal moves are either I can go up, or I can go down, or I can go left, or I can go right. Now, if we want to go up, then the jth index will be decreased by 1. Similarly, if we want to go down, the jth index will increase by 1. Similarly, if we want to go right, then the kth index will increase by 1. And here the kth index will decrease by 1. So these are the valid combinations which we have. Now let us code for this combination. So let us first code for the up condition. So for up, as we know, j minus 1 is how we will be able to go up. So for j minus 1, it has to be greater than or equals to 0. And pad of j minus 1 comma k should not be equals to star or hash. So if this condition is satisfied, then that is a legal move. Now if we are making a legal move, so let us say currently we are at index 5. So from 5, if we go up, the legal value we will get is 2, right? This is the legal move which we have. From 5, if you go up, we will get 2. So what we need to do is, this value is already there in index. This value also we need it. This value we need it. Why do we need this value also? This is because if we look here, in order, so for instance here, for n equals to 3 and when the value was 1, we know that the transition is 2, 4, 1. So these are the legal transition which we have. Now in order to solve for n equals to 2 and 2, we need this value also. And that is how once we know this value, then we can look into our DP table in order to get to this value, right? Because of which we will have to know this value also. Now this value, if you see, this value is essentially, so let me call this as next index. So this value, how we will be able to get to this value? Well, this value is essentially pad of j minus 1 comma k. And this, let me just put it into an int also. In this way, we will be able to get to 2, right? Once we know 2 and all this information, then in order to compute our dp of index comma I, this will be equals to plus equals to dp of next index comma I minus 1, right? I is, this is of length 3, then this is of length 2. And from 5, we have moved to 2, right? So this index is 2, next index is 2. And this is how we will be able to update our dp of index comma I. So please note, this is only for up case. We need to have 3 more conditions also. So the other conditions will be for down case, left case, and right case. And the final case will be, you can self press also. You can press the same button also. So these are the 5 legal moves which we will have. And in each of these 5 legal moves, the DP index will be updated in the same fashion as we have done. Which is, we will first find the next index. Once we have found the next index, then the DP of index will be updated in this fashion. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So for Python implementation, what I have done is, if n is equals to 1, then we are returning 10. Otherwise, we took a pad with us. Then a DP table is what we have instantiated. And then for n equals to 1, we have instantiated the DP table with dp of I comma 1 equals to 1. Then I'm iterating on 2, 2 and plus 1. And this is the we are iterating on pad. We are ensuring that the pad value is not equals to star or hash. If it is not equals to star and hash, then that simply means it is a number. So we are converting that number in integer format. Once we have converted that in integer format, then for down case, up case, left case, right case, and self case, we are updating the dp of index I. Now let us look at how we are updating it. First, we are ensuring that the down move is a legal move or not. If down move is a legal move, then if we are moving down, what will be the next index? So the next index will be equals to int of pad j plus 1 comma k. Once we have that, then the dp of index will be updated in this fashion. And similarly for up, left, right, and self case. And in this way, we will be able to update our DP table. Once we have updated our DP table, in order to get to our answer, we need to add the last column, which I am doing it over here. and towards the end I'm returning that sum. So that's the code, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.